For those of you that like algebra, today's your day because we do no geometry today. Some of you are like, yay. Some of you are like, oh, God, here we go. So, guys, this is an Algebra 1 section. You've already learned this. You're supposed to have learned this, but I understand that COVID, some of y'all got what you needed to out of Algebra 1 and some of y'all didn't. I'm going to teach this like you've never seen it before. So today we're going to be talking about ratios and proportions. Most of you are going to know this stuff, but if you don't, ask. I'll do anything I need to go over this. Again, no geometry today, just stuff that'll lead us into what we can do for the next 2 sections. So getting started today. We're going to be starting by talking off about ratios. So a ratio is going to be a comparison of 2 numbers by division. It is a comparison of 2 numbers by division. It's always by division. That's how it's set up. It is a comparison of 2 numbers by division. Now, there are 3 different ways to write ratios. Now, when you see something like odds, like betting, if you've ever been to Vegas, hopefully not because you're young, but if you've ever been to any place that they have betting of any kind, betting is used based on odds. You see this with football a lot of times when you see it on Saturday. They have a like 2 to 3 chance of winning. Okay? When you see this set up, it's going to be written like this. I think I use the numbers 5 and then a colon and then a 7. Ever been to a racetrack, to like a horse racetrack or a car racetrack? They do odds on a pole for you to bet using these. This is the odds. That's how they write them, is like this with a colon in between them. We won't use that much because mostly what we'll be doing in here is using ratios and proportions, which means they need to be written as fractions. Another way you'll see them in word problems is with the word 2 in the middle. So 5, 2, 7. Chances are 5 to 7 that it's going to rain today. Alright, it's also written as a fraction, 5 over 7. This is the way we will be writing them in here because this is the way we can use them in proportions. That's what we're going to be eventually doing with these. The only thing we need to talk about is going to be how we go through and set these up. When you're setting these up, thank you, sir. When you're setting these up, you're going to be setting them up based on the information that's in the problem. Whenever you set them up, you always just put whatever's first over whatever is second. So if we're going from sophomores to juniors, what number is going to go on top of my ratio? Sophomores. So it's going to be 20 over that 5. Now reducing these, some people have a little bit of a problem with this because you've been taught all your lives to reduce, 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 reduce. And you still are going to reduce. But if you reduce this, what's your answer going to be? It's got to be a comparison of 2 numbers. If it's still a ratio, then it really is going to reduce down to 4 over 1. It's not that it's wrong at 4 in that it is the correct answer, but if you're asked to give it as a ratio, then 4 is not a comparison of 2 numbers. 4 over 1 is a comparison of 2 numbers. So you have to be careful. Does it just say reduce or reduce to the ratio? If it wants a ratio as an answer, it'd have to still be 4 over 1. Now, they do need to be written in the simplest form. I put that on there. You are going to be reducing all your answers. Make sure you do that when you're working on your homework. I do want to talk about the fact, though, that the way that you read it does matter. If you read it differently, if it's written differently, your answers are going to be different. For example, if I'm comparing the juniors to the seniors, what would my ratio be? What to what? 5 to 4. Good. 5 over 4, because there are 5 juniors and there are 4 seniors. Wrote over the 4. 4 seniors. Now that, guys, as a percentage would be 125%. For every 5 juniors, there are only 4 seniors. But if I said seniors to juniors, what would that be as a ratio? 4 over 5, which as a percentage would be 80%. And for every 4 seniors, there would be 5 juniors. Alright, those are 2 very different numbers. 5/4 and 4/5 are definitely different numbers. So whichever one comes first, that's the one that's got to go on top. Please be careful about that. It will make a difference. Now, I don't foresee any issues with y'all writing basic ratios. My concern is when you get down to problems like this, which I'm going to put numbers 9 through 12 on your homework. Have some of this, so you got to watch for it. Okay, so I'm going to talk about converting. Why am I going to talk about converting? Because in this ratio you have two different what? Two different measurements, two different units. Both those words are correct. Units and measurements. Because of that, whenever you have this, the easiest way to do this is to always go and take whatever the bigger one is and change it into the smaller one. The reason it's easier to do that is because you will always be multiplying. It's easy to do that. If you just go that way every time, then it's always multiplication. You don't have to decide, am I multiplying now? Am I dividing? It's always multiplication if you go from the bigger unit to the smaller unit. So because of that, guys, our unit conversion is going to be inches and feet. Okay, 1 foot equals how many inches? 12 inches. So if I have 2 feet, 2 times 12 means really we're talking about how many inches? 24 inches. Take a second, get that down. I'm right ahead of anybody. Make sure you get that down, get that conversion. So instead of comparing 10 inches to 2 feet, we're really comparing 10 inches to 24 inches. So when you set up your ratio, it's going to be 10 on top, 24 would go on the bottom, and then you're going to use your calculator to make sure that you reduce it correctly. There's nothing wrong with checking it with your calculator. And what does that reduce to? 5 over 12? Is that what y'all got? Okay. Oh, because both of them just divide by 2? That's not too bad. All right. Anybody see anything on that they need to ask about?
Can you remind me how to do it on the calculator?
Type it in?
Yeah.
Absolutely. Just type 10, fraction button, 24, and hit equals.
Oh.
Yeah, guys, please, that's the kind of thing you need to ask. I can't tell you how to use the calculator during a test. I can't tell you how to use it during the EOC. I'm not allowed to, but now is a great time. Ask me anytime you need to know those things. People forget. That calculator's convoluted. Okay, guys, real quick, I want to put out here to the side some of the units that you use to convert with. Let's see, inches to feet. Oh, feet to yards. If I have 1 yard, it equals how many feet? 3 feet. What's the other conversion that y'all have to use? Centimeters to millimeters. 1 centimeter equals how many millimeters? Ooh, 10 is correct. 10 millimeters. Because this is 1,000, 100, this goes to 1,000, so you have to multiply by 10 to get these littler units. So it is 10 millimeters in every 1 centimeter. These are the other two. If you have any others on the worksheet, let me know, but I know these are the other two that are used on the worksheet. Okay, guys. So from there, the next thing that we're going to be dealing with is what's called extended ratios. Now, extended ratios are never written as fractions. These are ones that are going to be longer. These are going to be applied to word problems. For example, an extended ratio might be used in a problem where it says the perimeter of a shape is going to, let's say a rectangle. The perimeter of a rectangle is 50. Okay. The ratio of the length to the width is 2 to 1. Find the length, find the width. That's the kind of problem we're talking about. Alright? So let's talk about what an extended ratio is going to look like, and then we'll apply it to a problem down here. So an extended ratio is just going to be a comparison of 3 or more numbers. That's it. Instead of comparing 2, now you're going to be comparing 3 or more. Now mostly ones we're going to be doing are going to have 3. Most of them, but 3 or more. Okay, it's set up like this: A to B to C. Okay, so in this problem we've got a triangle. First, guys, if you don't have a picture in the geometry problem, draw a picture. Those 3 sides are in a ratio of 5 to 12 to 13. Now, does it say that they are 5, 12, and 13? That's their lengths. No, it says their ratio is going to be 5 to 12 to 13. That's how they're related to each other. Okay? What it says is the perimeter is equal to 90. Well, guys, how do we get the perimeter of anything? We what? add up the sides. How many sides do we need to add up? 3, and it's going to equal 90. Now the sides aren't 5, 12, and 13. They're 5 times some unknown amount plus 12 times some unknown amount and 13 times some unknown amount added all together. Now, if they just ask you for listen guys, this is like number 2. I'm going to put this out here just so you know. Number 2 on your homework messed people up. They thought it was some big problem they were trying. If they just say, what is the expression of the sides right here in terms of x, it would be 5x to 12x to 13x. That's the expression. If you want to write that by it, this is an expression. Because there's no what? What makes it? What's different from an expression to an equation? There's no equal sign. We're not trying to solve it. That's just the expression of these sides. Now, if you want to talk about the equation that's going to let us find out how long the sides are, well, we're just going to fill them in here. 5x plus 12x plus 13x is going to equal the perimeter, which in this case is 90. Okay, guys, we're going to do like terms, but guys, all 3 of them are like terms, so really all we're doing is adding them up. So what's 5x plus 12x plus 13x? What was it? I got different numbers. Which one is it? It's 30. 30x equals 90. Okay? To solve that, it's just a one-step equation. Which number are we dividing by? 30. So x equals 3. Now, here's the problem. Someone's going to stop there and they're going to have that as their answer. Even though they've done everything right, they're not going to get the problem correct, because what it asks for is for you to find the lengths of the 3 sides. How would I get the lengths of the 3 sides? Plug it back in. That's correct. So 5 times 3 would be 15. 12 times 3 would be 36. And then 13 times 3 would be 39. There we go. That would actually be the answers. The things that are circled there, the 15, the 36, and the 39 would be the answers to the problem. Now, problems like this lend themselves to find them and check them very easily. What could I do to easily check this problem? And what should it equal? 90. And if you add up 15, 36, and 39, it does equal 90. Now, again, if I did the same thing, just real quick, don't have to write this down, guys, just pay attention for a second. If I said angles were in a relationship of 5 to 8, and they were supplementary to each other, what would my equation be? 5x plus 8x equals 180. What if I said they were, and again, this is not to be written, this is just for y'all to see, I'm just kind of things I know that are going to be something you have to deal with. What if I said 2 angles were in a relationship of, let's stick with the 5 to 8, but they were now complementary? What would it be? Plus 8x equals 90. There you go. Okay. Just to kind of mention some things that I know are going to be on there. Anybody see anything before we move on? We'll go to proportions next. Nobody? Okay, here we go, guys. I think this is where the biggest thing that's going to be new vocab-wise, there are 2 words on here that are going to matter in the next 2 sections that you may never have heard of before. This is a thing that I want you to kind of put a star beside, highlight, whatever you do to remember things. These are things that I want you to see. Everybody has seen a proportion before. This is a proportion. You've seen it. It's going to just have 2 fractions right here, or 2 ratios set equal to each other. And as a matter of fact, that's our definition for it. It's going to be 2 ratios set equal to each other. Okay, so it's 1 ratio set equal to another ratio. That's going to make a proportion. Just while we're mentioning it, because most people have solved them before. If you haven't, it's okay. I'm going to teach it like you haven't. But if you have, How do you solve a proportion? Ooh, I got that right away in my others. Y'all don't remember this? Cross multiply. As soon as I do that, usually people get it. Cross multiply is correct. So, based on that idea of cross multiplying, you connect these two pieces together. That first one and the last one, the A and the D, are called the extremes. This is going to be the thing that, like, this is the thing that we have something called the geometric mean later, and you got to know which ones are the extremes and which ones are the means. So this is a big deal later on. Okay, and later in this chapter, I don't know if it's before or after the break, but I think it's before. And then B and C, the ones in the middle, are considered the means. M-E-A-N-S, means. Every proportion is going to have two cross products. I mean, if you multiplied it across, you would get two cross products. Those cross products are the extremes, meaning A times D, and the means, which is B times C. The extremes and the means. When you cross multiply them, you're going to get those. Now, let everybody get that down. I'm going to write some. You don't have to write this down, guys. This is just for explanation purposes. If you want to, you can, but it's not required. Okay. So you see this a lot, guys. 1/2 equals 2/4. Usually you see it the other way around. Usually you see 2/4 equals 1/2 because we reduce a lot. Okay? Those two fractions are what to each other? Equal. They're equal to each other. And in a true proportion, not only are the two ratios equal to each other, but their cross products are also going to be equal. So anytime you have a true proportion, the extremes have to equal the means. In a true proportion, if you multiply A times D, that has to equal B times C. We're going to use that to solve with, so that's a big deal. All right, anybody have any questions before we talk a little bit more about proportions and how they're related to each other? Okay. Everybody good? I don't want to get ahead of anybody. Good? Okay. So, guys, this next one is not any we're not solving in this one. You're going to see these problems on the homework. These actually were more, I had more questions on this than on the solving. This is about how numbers are related to each other. So, if we cross multiplied this, it would be 7 times x on this side, and it would be 6 times y on this side. Okay? I need to keep this true proportion, this relationship, the same, even when I rewrite them in different locations. So, look how these are related to each other. That x is connected to the 6. The y is connected to the 7. So if I have x on top and y on bottom, I've still got to connect that x to what? 6. And the y is going to have to be connected to the 7. Now, if I cross multiply this, do I still get 7x equals 6y? 7 times x, 7x. And then 6 times y. Do you need some water, sweetie? You need some water? I don't know who's coughing. Oh, you got it? Okay. If you need some, let me know. If anybody, guys, everybody's like, all the sniffles, everybody's back around each other again in the winter. It's starting to get everybody coughing and sniffling again. If you need water, feel free to get up and go get it. Okay, guys, the last one, we've got to keep that relationship the same. So even though it's on the bottom, we still need that x connected to the what? 6. And the y's got to be connected to the 7. If I cross multiply, do I still have that same relationship? 7x equals 6y, yes. So do you see that you can write a proportion in lots of different ways? You can flip the numbers, move it. As long as the same things stay connected to each other, you still have a true proportion. Okay, so the last thing's going to be solving. I only put a couple of these on here because usually this is the part, like I said, I don't get many questions on this. People tend to do well on this part. So we'll see what it is that y'all need to ask about. I've got a couple of them, and there are a couple of like more involved ones that you'll see. So when you see these problems, you're going to multiply 6 times everything that's up here and 3 times everything that's up here. These are cross products. Remember though, if there's more than one thing up there, you got to treat it like there's a parentheses. And what property is that when you have something times a parentheses? Distributive. So I've got to distribute that 6 to the 4x, which is going to be 24x, minus 6 times 5 is going to put me at 30, yes, equals, what's 3 times negative 26? Negative 78. There we go. Equals the 3 times the negative 26. So 3 times negative 26 is equal to that negative 78. Good. I'm sorry, sweetie. Feel free if you need to. You're okay. It's not look, it happens. If you need to, feel free. Okay, guys, here we go. Plus 30 plus 30. Solve it like a regular equation. It's going to be 24. I'm sorry, sweetie. Equals negative 48. Divide by 24. Divide by 24. And x equals, is it negative 2?
Yeah.
Negative 2. Even? Yeah. There we go.
And it can be negative to this?
It absolutely can, because we're not talking about something that's a distance. We're not talking, it's just a proportion. Good question. We're so used to that in geometry that we have to be careful. Okay, cross multiply on this next one. Again, we need to think of this with parentheses, but the parentheses happen to be on the ones on the bottom. So it's going to be the x times the 7, which would give us 7x, plus the 4 times the 7, which would be 28. On the other side, the x has to be multiplied times the 9, which gives us 9x, minus the 1 times the 9, which is going to give us 9. And it doesn't matter. You could have put the 9x minus 9 in front and the 7x plus 28 on the other side. It doesn't matter. It's just if you do any comparing like greater than or less than stuff, then it's going to put it where you got to have it in that order. So I tend to always go up and to the right and then up and to the left over here. Because that, if you're going to do inequalities, it does have to be in that order. From there, we're going to solve it. Minus 7x minus 7x. 28 is equal to 2x minus 9. Add 9, add 9. 37 equals 2. Oh, it's not a whole number. It's a decimal, isn't it?
Yeah, 18.5.
18.5, thank you. Now, I will tell you this. I think there's one on your homework. It's like in the teens. I can't remember exactly what number. There is one that, guys, when you try to turn it into a decimal, it's something like 7/3 or something like that. I can't remember exactly what it is. But if you get an answer like this, your answer will just be 7/3 equals the variable. Okay? If you can't, 7/3 doesn't do nice things on a calculator. There's no nice decimal. If it has a nice decimal, you can give me the decimal. If not, do not round. Give me the fraction. Okay, guys. So that's it for today.